Hey guys, this video we're going to talk about an actual real-life application of a composition of two functions. So in this example, we have a store, has shirts on sale for 20% off, and you have a $10 off coupon. A shirt costs X dollars. So first, let's write a function to represent the cost of the shirt after the 20% discount is applied. So with percents, you want to think about what you're taking off versus what you're still going to be paying. So I'm just going to write P of X for percent. So even though the 20% is what they're taking off, we need to put this in terms of how much we are still paying. So if they took 20% off, we are paying 80%. So you have to remember with percents, when you're working with them in math, you have to move the decimal 2 places to the left. If that's too hard to remember, then divide by 100. But we're paying 80%. So they're taking 20% off, but we're putting it in terms of how much we have to pay. We're paying 80% of the shirt. All right, write a function to represent the cost of the shirt after the $10 off is applied. So we'll just use the letter C for the cost. So in this case, this is pretty simple, right? We have however much the shirt cost originally, and they're just taking $10 off. So that's how much we're going to pay. All right, does it matter which discount is taken first? So this is where we're going to compare the $10 first and then the 20% discount versus the 20% off first and then taking off the $10. So these are like the ones that you had a couple of days ago where you're making an entirely new equation. You're just putting one equation inside of the other equation. So in this case, this time around, I'm putting the x minus 10 inside of the 0.80x. So I'm going to write, there's my 0.80x, but instead it's the x minus 10 function. All right, versus the 20% off coupon getting plugged into the x minus 10. So I'm going to write my C function. I'm going to leave a space because there's x minus 10. And inside of that is my 20% off. All right, so I'm just going to distribute here just so we can see if these two are actually the same. If these two come out to be the same exact function, then there's no difference in which coupon we do first. So I'm going to distribute. .80 times x, 0.80 times 10. All right, versus this, there's no distribution here, and those are not like terms. So this is going to be 0.80x minus 10. So you might be able to tell just by looking at these equations that if I'm taking $10 off, that's going to save me more money than only taking $8 off, because the 0.80 is the same for both equations. But let's do it with a dollar amount, just so we can see. So let's say we have a shirt that was $100. So in this scenario, we started with $100. Since we did the $10 off coupon first, we're up to a $90 shirt. Then we did the 20% off coupon, so we paid 80% of $90. So in this scenario, we are going to pay $72 for that shirt. All right, the same shirt, it was $100. In this scenario, we did the 20% off coupon first. So that's going to be $80. And then we take the $10 off. All right, so we can see that the $70 shirt is obviously cheaper than $72. The bad thing for you is stores know this, and so typically when they are running a sale that's a percent and you also have a dollar amount coupon, they do this first because they know that that's going to save you less money, which means they get to keep more of your money. All right, so we're going to do a few more examples like this in class, but the premise is the same for both of them.